Dear students, in today's session, we are going to discuss about 2D and 3D shapes. So you might have seen many objects around you. Every day you watch many objects around you. Few of them will be two-dimensional and few will be three-dimensional. So let's see what is the difference between 2D and 3D. So the shapes here are square, rectangle, triangle, circle. Okay, these all figures are two-dimensional figures. Okay, whatever looks like these shapes, whatever looks like these shapes. Okay, it can be a blackboard, it can be a piece of a bread. Okay, or it can be a chapati, circular shape, whatever it looks, or a coin. So those all figures comes comes under two-dimensional figures. So whatever objects we see around us, they are classified into two types, two-dimensional or three-dimensional. So you have learned the formulae of few of 2D shapes in the lower classes. Okay. Now let's have a look at few 3D shapes. A an oil tanker. Okay, you can see an oil tanker. It is in the form of cylinder, right? So and the tires of this tanker is also 3D. Okay, they are 3D shapes, they are solid shapes. Or you can have a look at the missiles or rockets or an ice cream cone, the pillars, okay, in a palace. These all, okay, these all objects are three-dimensional, or they are called solid figures. So basically the objects are divided into two types, 2D and 3D. So we are going to learn the formulae of different 3D shapes and 2D shapes, and we are going to learn how these 3D shapes are formed using two-dimensional objects. Okay, we need two-dimensional objects for making three-dimensional objects. So our chapter is surface areas and volumes. Okay, surface areas and volumes. And we are doing introduction to this chapter. This chapter will be very simple if you understand the formulae and how to apply the formulae, way to apply which formula. So let's begin with the formulae of 2D shapes, few of 2D shapes, then we'll go in 3D shapes. So the formulae which you need, the 2D shapes formulae which you need are the formula for square. Okay, formula for a square. Let me change the color. The first 2D shape, two-dimensional objects. The first 2D shape I'll take is a square. Okay, you have been learning about the formulae of square. If I take a square of side A, if you take a square of side A, the area of this square, area of square will be A into A. Okay, that is side into side. You can say side into side or A into A, that doesn't matter, and that can be written as A square. So area of one square, okay, is A square. The perimeter of this is 4 times A. Okay, these are the formulae of square. Then let's have a look at the next 2D shape, that is, this is called rectangle. Okay, you must note down all this formulae in your book. Next, in the rectangle we have length and breadth. Everybody knows that. And area of rectangle is L into B. How will be the floor of your room? A room which is cuboid in shape, the floor will be rectangular. The walls or the blackboard, the green board in your classroom, they all are rectangular shape, okay? And they are 2D shapes unless we consider their thickness. If we ignore their thickness, then it is 2D. If we consider the thickness of a board, then it is of 3D shape. If you consider the thickness of a wall, then it is 3D shape, okay? Perimeter of rectangle is 2 into L plus B, okay? That is the length of the boundary of this rectangle is 2 into L plus B. Next, let's take another 2D shape, that is circle, okay? Which we need for making 3D shapes. So we need a circle for making 3D shapes, and you have learned the formula of circle, that is, this is the center of the circle, and this distance from the center to the circumference is called radius, okay? You have learned this in the previous chapters. So area of circle whose radius is r is pi r square, okay? This is area of circle, and circumference of circle is 2 pi r. That is the length of the boundary of the circle, okay? Now these are the basic shapes which we need for making different 3D shapes. Using a cube, which 3D shapes I can make? Using a cube I can make using a square I can make a cube, okay? Using the squares I can make a cube. Using the rectangles and square I can make, what can I make? I can make a cuboid. Using the circle and a rectangle, okay, I can make a cylinder. So different objects, 3D objects can be made by using the 2D shapes. So these are the formulae which you must remember for understanding the concepts, for understanding the formulae of 3D shapes. Now let's learn the formulae of 3D shapes one by one. Let's begin with a cube, okay? A cube is a six-sided figure, okay? Like a box. It can be a box, okay? Whatever you order online, you get it in a box. So, or it can be a rubric cube, okay? It can be anything around you. So, a cube has 6 faces. Just now we learned the formula, okay? And all the 6 faces are of same size and same shape, that is, all are squares. So if I take a cube of side A, okay, all this will be A, length, breadth and height. Imagine this is a cubicle room. So these 4 walls, okay, there are 4 walls in a cube, the surrounding, okay, these are called 4 walls, and the top one is called ceiling, okay. Imagine this is a room with a fan at the top, and this is the floor of the room, okay, floor of the room, and these are the walls, W1, W2, W3 at the back and W4 in the front. So whenever you want to find the area of the 4 walls, okay, area of the wall, suppose you want to paint the walls of the room, so we find lateral surface area here, LSA. Lateral surface area of a cube will be 4 times a square, because area of one square is a square and there are 4 walls, so it will be 4a square. Then total surface area of a cube will be, total means all the faces, that is, how many faces do we have? 6. That will be 6a square. Then volume, what is the capacity of this room? Or imagine if this is a tank, a water tank. What is the capacity of this? Volume is nothing but capacity, how much water it can hold or how much air does it have. So that is volume, that is volume of cube is a cube. So these are the formulae of cube. Let's go for another shape now, that is a cuboid. Okay, let's see how a cuboid is formed. A cuboid, okay, you might have seen rooms, boxes, okay, and many more things which are cuboid in shape. So cuboid has how many faces? Even cuboid have 6 faces. A cuboid has length, breadth and height. So if you want to paint, like imagine this is a room and you want to paint the walls of a room. So how many walls will be there in a room? 4 walls. That area of walls, 4 walls, is called LSA, lateral surface area. The formula for lateral surface area is 2h into L plus B. By using this formula, we can find LSA, lateral surface area, or area of 4 walls. Then if I want to find, suppose imagine this is a box, a cardboard box. If I want to find how much cardboard is required for making this, so I find TSA, total surface area. Total surface area means area of all the sides, all the faces, 4 walls, the ceiling and the floor. Okay, so TSA will be, you learned this formula in your previous classes. It will be 2 into LB BH plus LH. Okay, then comes volume. Imagine this is an aquarium. Okay, this is an aquarium filled with water. So how much water this aquarium can hold? What is the capacity of this? So for that we find volume. That volume of cuboid is L into B into H. So this chapter is completely based on the formulae. If you remember the formulae, then only you can solve the questions of this chapter. Next, coming to the next 3D shape. Now let's take another shape, this one. What do we call this shape? This is a cylinder. Okay, you'll find many things which are cylindrical in shape. Just now I showed you one figure, a few figures in which you have seen pillars, cylindrical shape pillars, and you can see this oil tanker is also cylindrical in shape, and these rockets or missiles, whatever, they are also cylindrical in shape. So how do you find the areas of cylinder? So for a cylinder, 2 dimensions will be given. That is the radius of the base. How will be the base of a cylinder? It will be circular in shape. Okay, so there will be 2 circles, one at the base and another at the top, and a rectangle. If I say you ask you to make a cylinder, okay, you can take a rectangular sheet, fold it, then fix 2 circles, one at the base, another at the top. Okay, just fold this sheet, put 2 circles, one at the top, another at the base, you'll get a cylinder. Okay, so for cylinder, the dimensions will be given: the radius of this circle, the radius of the circle, the base or the top, and height. These 2 dimensions will be given for a cylinder. So imagine you have a cylindrical shaped barrel at your home. Okay, and you want to paint the surrounding of the barrel. You want to paint, or imagine there is a cylindrical pillar. There are many cylindrical pillars in a mosque, and you want to paint the walls, paint the cylindrical pillars. Okay, paint the cylindrical pillars. So for that we need to find curved surface area of cylinder. What we will find? Curved surface area, that is CSA. In the case of cube and cuboid, it is called LSA. In case of cube and cuboid, it is called LSA, lateral, the surrounding area. In the case of cylinder, it is curved surface area because the faces are curved here. Okay, so curved surface area of cylinder will be pi r 2 pi r h. Okay, curved surface area of cylinder, that is surrounding area of cylinder, is called 2 pi r h. 2 pi r is nothing but the circumference of the base. Yes, the circumference of the circle is 2 pi r. So circumference of the circle into h will give you the curved surface area. Now if I want to find total surface area of cylinder, for that, in this curved surface, total surface area of cylinder, for that I need the curved surface 2 pi RH plus two circles. Okay, this circle's area, if I add, what is area of each circle? It is pi r square. How many circles are there in this cylinder? 2. So in curved surface area, I'll add two circles area. So here we get 2 pi r common, remains h plus r. This is TSA of cylinder. Then next comes the volume of cylinder. Volume of cylinder means capacity. How much water can be filled in this cylinder, or how much oil can be filled in this cylinder, or ice cream, whatever it is. Capacity, that is volume. So volume of cylinder is area of the base, that is pi r square into h. Okay, pi r square, that is area of circle, into h. So that will give you the volume of cylinder. Then next we have next have a look at another shape, that is cone. Okay, so whenever you look at this shape, you'll remember of ice cream cone. Okay, so there are many things which are conical in shape. The top of the minaret, the cones which you eat, okay, the cone birthday caps. There are many shapes which are of conical shape. So cone has two faces. One is curved face, another the one is the curved face, another is the circle, the base. Okay, you can have a look here. The curved face, okay, that is the wrapper that will be wrapped with the company's wrapper, and at the top there will be a circle. No, in when you open a cone, there will be a circular paper at the top, that is circle, and another will be a wrapper. Okay, then you start eating the ice cream. So conical shape. In a cone, there we need the radius of a circle. This height is called h, and this is called slant height. This L is called slant height. So there will be two heights in a cone. One will be slant height, another will be just a height. Okay, so these three dimensions are needed to find areas and volumes of cone. Imagine you have only radius and height of a cone and you want to find slant height. So here I can apply Pythagoras theorem, because this forms a right angle triangle. So applying Pythagoras theorem, I can say L square is equal to h square plus r square. This is the formula to find slant height of a cone. Okay, now why do we need slant height? For finding curved surface area. Suppose you want to find CSA, curved surface area of a cone, that is the surrounding area, only the surrounding area, excluding the base. This base will not come in curved surface. Like ice cream wrapper, you purchased an ice cream cone, there will be a wrapper around it, no, the company's wrapper, that will be around curved surface area. So to find curved surface area of a cone, we use the formula pi r l. Okay, in curved surface area, if I add the base, that is the circle, okay, in curved surface area, if I add circle, that is pi r square, then I'll get TSA, total surface area. Then what can I take common from here? I can take pi r common. Yes, pi r and pi r can be taken common, remains L plus r. So this is the formula for TSA of a cone. Next, capacity of a cone, volume of a cone. Okay, volume of a cone will be 1/3 of volume of a cylinder. Okay, if you take a cone and a cylinder of same height and same radius, okay, if you take a cylinder and a cone of same height and the same radius of the circle, then how many cylinders you can fill with this cone? You can fill three we need three cones for filling this one cylinder. Like you want to fill this cylinder with water, okay, using a cone. So you need to put three cylindrical containers to fill this. So that's the reason we say volume of cone is 1/3 of volume of cylinder. Okay, volume of cylinder was pi r square h. So volume of cone will be 1/3 pi r square h. So you must remember these all the formulae. Then we have two more figures to do. Next is a sphere. Okay, ball. Okay, whatever looks like a ball, that is a sphere. The earth, okay, earth is also spherical in shape. So for finding the surface area of a sphere, we need the radius of a sphere. Okay, for a sphere, like if I draw a sphere here, yeah, let me check. Yes, here it is. So in a sphere, the shape which looks like a ball, we need the radius of the sphere. Okay, if I know the radius of a sphere, then I can easily find the surface areas. So a sphere has only one face in it, right? It doesn't have two or three faces. There is only one curved face. So you call it as CSA or you call it as TSA. It's same thing. Or you call it as surface area. Surface area is nothing but TSA. So CSA and TSA both are same for a sphere because it has only one face. It doesn't have two faces. So the formula for surface area of a sphere is 4 times area of a circle. Okay, that will be 4 times area of a circle. And the volume of a sphere is 4/3 pi r cube. 4/3 pi r cube. This is the volume of the sphere. Okay, let me write this 3. Okay, so these are the two formulae for sphere. Now if I cut a sphere into two parts, equal parts, okay, like if we divide the globe into two equal parts, we get northern hemisphere and southern hemisphere. So the half of a sphere is called hemisphere. How many faces does a hemisphere has? A hemisphere has two faces, face 1 and this is the face 2, right? One will be the curve, half curve, another will be a circle. So if I want to find the curved surface area, only this part is called curved surface area. So CSA of a sphere, hemisphere will be 2 times pi r square because the total was 4 pi r square. The total sphere surface area was 4 pi r square. So half of that will be 2 pi r square. Then TSA of this will be 3 pi r square because we add one more circle, face 1 plus face 2. Face 2 is nothing but a circle. You can see this is a circle. Okay, like you cut a watermelon into two equal parts, you'll get a red colored matter, okay, visible at the top. So that is a circular shape. So TSA of sphere will be 2 pi r square plus one more pi r square. Okay, this is 2 pi r square and plus pi r square, that gives you 3 pi r square. And the volume of hemisphere will be half of the volume of sphere, 4/3 pi r cube. So that will be 2 times, and you get the volume of hemisphere as 2/3 pi r cube. So these are the formulae which you must remember for doing this chapter. Okay, so all these formulae you must learn and note down in your classwork. Okay, so these all the formulae I have given it in the tabular form for your convenience. Note down these all the formulae and learn them. Be ready for the next session. We'll start solving the questions. In this class 10th, we are going to learn many unique things in this chapter, surface areas and volumes. Okay, so our chapter name is surface areas and volumes. Okay,